Heavenly Father, you're so good, you're so great. There is no one like you. We thank you for this blessed lesson, Heavenly Father. Heavenly Father, forgive us wherever we have gone wrong. We call upon your Holy Spirit to come and enable us understand whatever is going to be taught. We dedicate this lesson into your precious blood. Heavenly Father, we call upon your wisdom. You said in James 1:5 that those who ask for wisdom from you will be given graciously and abundantly. Heavenly Father, come and reign in this lesson. Come and bless us in this lesson. Come and bless the teacher in this lesson. In Jesus' name I've prayed. Amen.
Amen. Thank you so much, Chisachi Mark, for the word of prayer. And you are most welcome, everyone. Yesterday, you requested that we go through function. So that's what we are going to look at today. And we shall start with a summary of what functions are. Now, I know in senior 2, you covered something about functions, and also in senior 4, you went on and covered something concerning functions. Now, in functions, these are the things at least you need to know. One, you need to know what to call a domain. And when I talk about a domain means a set of X values. Then you need to know about what we call a range. Range, this is the set of Y values. Take an example. When you have your Cartesian plane, the values you have along the values you're going to have along the x-axis, all these values are going to constitute your range because this is the x-axis. Then the values you're going to have along the y, these are what constitutes your range. So range refers to the y values, and the domain, those are the x values. Take an example. They can tell you that the domain has these values. Let me say -1, 0, and 1. And then they ask you to get the range values. Here they can give you a function. Let me say f of x is equal to 2x. That means that in order for you to get the range, all the values for the y, you'll come here and substitute. So you substitute your -1 to get -2. You substitute your 0 to get 0. You substitute your 1 to get your 2. And this is the set that will have the range for your values. Secondly, another thing here that you need to know is that the different types of mapping. We have the different types of mapping. And when we talk about mapping, we are referring to the relation that exists between your values in the domain and the values within the range. Now we have the different types of mapping. And the first one, we have what we call a one-to-one mapping. Now a one-to-one mapping means that you have, let me say this is your set and this is your set. Here you have a condition that in case I have 1, 2, let me say this is 2, this is 4. Here, one element in the domain maps to one element in the range. One element in the domain maps to one element in the range. That is what we call a one-to-one mapping. Sometimes we can call these ones an input, and then we call these the outputs. So that is what you need to know about one-to-one mapping. That every element in the domain maps to only one element in the range. We call those ones one-to-one mapping. Then we have what we call many to many mapping. Now, many to many mapping, it means that you have very many elements this side, mapping to many elements this side. Let an example, you have 0, -3, 2, and you have, let me say, 1, 4, -2, 7. So you may find this 0 going to 1. You may find the same 0 going to 4. You may find -3 going to -2, the same, this 2 going to -2, this 2 going to 7. Now, this kind of mapping is what we call many to many, that one input here has many outputs this side, like you see 0. that this 0 is related to 1 and 4. This 3 is related to -2. This 2 is related to -2 and 7. So you find that this -2 has two inputs, has -3 and has 2. So we can call this one many-to-many mapping. Then we have what we call one-to-many. One-to-many, it means that one input this side has very many outputs this side. Take an example. In case I have 1 and I have 1 and 5, you can notice that this one is mapping onto 1, this one is mapping onto 5. So such a relation is what we call one to many, that one element has many outputs here. That is the meaning. Then the last one, we have what called many to one. Now, many to one, it means that this side, let me say I have 0, I have 5, and maybe this side I have 9. So it means that here 0 to 5. So this one means that two inputs have one element. So 2 to 1. So as long as something goes is 2 and more, then we call that many. So this means many to 1. An example here, we can give 1 to 1 in real life. It's like having every child has one mother. So you cannot be having more than two mothers. So one child, one mother. That one we can say that's a 1 to 1. However, we can have one child, one mother with many children. That is one to many. You can have one parent, a mother can have many children. Then many to many, this one you can use many to many. You can look for an example whereby many things to many things. Then many to one, this one you can find very many ladies to one man. So that one can be some of your examples to help you remember the different types of mapping. Now, these types of mapping, how are they going to help you? One, sometimes you may be dealing with a number and they may ask, does it form a function? Does that number form a function? Now you need to know which types of mapping give us functions, or for something to be called a function. What is the condition for something to be called a function? Now, for something to be called a function, one, we expect that for anything to be called a function, one of the conditions that is going to be is that the input is 1. So one of the examples of those that give us that gives us something to be called a function, I want people in the chat to let us know. Is it 1? This is 1. This is 2. This is 3. And this is 4. Which type of mapping here can result into a function? You can put 1, you can put 2 or 3. Put in the chat and we see whether we remember something on that. Mhm. Okay, I've seen your answers. So one of them is one-to-one mapping. And then the next one is many to one. Those are the only two that will give you what we call a function. So for something to be a function, it must have one output. For something to be a function, it must have one output. So here, it would only be this one and many to one. For anything to be a function, you can only have one output. An example can be f of x is equal to x. Here you can only have one output. An example of minute one is f of x equaling to x squared. Here you can have two values. Let me say for f of x is equal to x squared. Let me say you can have -1 and 1. These are two different values for input, but they will give you one answer always. So this one and this one are not functions. So sometimes they will give you a question, and then at the end of the say they ask you to make a conclusion to ascertain whether it is a function or whether it's not a function. So for something to be a function, it must always give you a single output, much as the inputs can be many, but the output should strictly always be one output. Okay, let me hope that is very fine. Okay, so we are going to continue. So that this is a simple summary about those mappings. Then when it comes to the composite functions, for composite functions, what do you need to know? One is a composite means that we have two things that have been combined and they want us to get one combined thing. Take an example. In case I have f of x and I have g of x. In case my f of x, let me say, is 2x plus 1, and I have my g of x as maybe, I have it as maybe 3x. If they tell me that they want me to find fg of x, what does it mean? It means that you have two functions and one function is the input for the other. The way you see the machines, let me say this is your first machine of f of x. Then this is your second machine of g of x. So when we say f g of x, it means that get this g of x and put it inside f of x. So gx is the input for f of x. So when we say find f g of x, it means that f of g of x is going to be the input for f of x. In other words, first get g of x, the answer you get, put it in f of x. So here it means that I'll have f into g of x, which is 3 of x. Now, wherever in f of x we have x is where you are going to be placed. So remember our f of x is given by the 2x plus 1. So that means that where there is x here is where we put g of x. So this will give us 2 into 3 of x, then plus 1, which will give us the 6x plus 1. In case I have f of x maybe equals to x plus 1, and I have my g of x as x squared plus 2 of x. Now, in case I'm finding gf of x, it means that wherever in g there is x, I'm going to put f. So in other words, when I come in g, it means that where there is x is where I put f of x, everything squared, plus 2, where there is x is where I put f of x. That is the meaning. That wherever there is x, you replace it with f. Wherever there is x, you replace it with f. So for such a case, we shall have x plus 1, everything squared, plus 2 into x plus 1. Kindly let me know whether that is very clear through the chat. Is that clear to everyone? Okay, okay, okay. Okay, now we are going to start with our first case. So that is a simple summary. Now, another thing they can ask you here on this number, they can also ask you to draw the graph and also find the inverse. They can tell you that sketch the graph of f of x plus 1 and then find the inverse. So they can give you a graph to sketch. Let me say they can give you a graph of this nature to sketch. And then let me say they can say g of x is equal to x squared and they tell you to sketch. So, and here they can give you from 0 to maybe 5. So now you'll sketch your graph and the graph will look like that. Now, after doing so, they'll ask you, this is your domain, 0 to 5. And then they can ask you that, go on and find the inverse. You show on the graph the inverse of this. Now, whenever they ask you to get the inverse it means you reflect what you have sketched. Let me say this is your g of x. You reflect what you have gotten on along the line y is equal to x. So it means that you are going to draw another line here, which is y is equal to x. Now, for whatever point you have plotted here, you reflect it along this line. So that means your graph will look like something like this. Kindly let me know whether that is okay. Also for inverse, is the inverse fine? Let me see. Oh, no. Okay, people have said no. Okay, I'm going to repeat. Let me first do it here. Let me create. Now, when they tell us to find the inverse of the function, I'm going to give you, and let me say, they have given us, they have told us that g of x, given that g of x is equal to x squared for 0 less than or equal to x less or equal to 5. Show the graph on, show the function on the graph and find its inverse. So the first thing you're going to do, you're going to first draw your table where you have x and where you have g of x. So you say this is 0, 1, 2, 3, 4, and 5. Something like this. Now you substitute, you have your g of x equals to x squared. So you start, when g of 0, what do you have? 0 squared, which is 0. So here you have 0. When you put in 1, you'll have 1. You put in 2, you'll have 4. You put in the other one, you'll have 9. You'll have 16, and you'll have 25. You just substitute your x. You say now g of 1 will be 1 squared, which is 1. G of 2 will be 2 squared, which will equal to 4. Now, after doing so, you'll come here. I say that for anything you plot on the graph, extract your coordinates. Extract your coordinates 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and 5 and 25. Now, after doing so, you are going to plot. You are going to plot. Now, when you are plotting, you plot the normal way we do the plotting. So I'm going to come here on my graph. This is my graph from 0. This is 1. This is 2. This is 3. This is 4. And this is 5. Then along this side, I'm going to plot. Allow me to say, I'm going to plot it in form of this is, let me say, this is 5. This is 10. This is 15. This is 20. And this is 25, somewhere there. Now, after drawing so, the next thing you're going to draw is your line of reflection, which is y is equal to x. Always, 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 please take note. It is the reflection along the y is equal to x. It is the mirror line. So you'll come here, still develop a simple table. You say 0, 1, 2, 3, 4, 5. Then what will be the y value? Your y is equal to x. Where there is x put 0, you will get 0. Where there is x put 1, 1, 2, 3, 4, 5. So you will end up still with 0, 0, 1, 1, 2, 2, like that. Now, you draw this line, y is equal to x. This is your mirror line to reflect the curve you're going to draw. So I'll come here. I know that line. 0, 0 will be here. 1, 1 here, like that. So that line, the mirror line, is going to be a line of this nature. Like that, like that, like that. That is going to be your mirror line. So you can even call it, this is the y is equal to x, which is your mirror line. Then from there, you are going to draw your curve. Now you plot 0, 0 is here. When you look at 1, 1, 1, 1 can be, let me say it is somewhere here. Then you go to the next 2, 4, 2 is here, 4 is somewhere here. Then you go to the next 3, 9, 3, 9 is somewhere here. You go to 4 like that, like that. So at the end of the day, you're going to find out here, please, for you, you must do it on the graph. I'm just using this for demonstration. So you'll find that your graph is like that. Now, what you do, you reflect these points. Whatever point you have plotted here, you are going to reflect it. Now, to reflect it along the line, it means that since this y is equal to x, your x interchanges, it becomes your y, and your y becomes the x. So what you had as 0, 0, you are going to plot 0, 0 after reflection. So it will come back here. What you had as 2, 4, now it's going to interchange. You'll have 4 and 2. So you'll come here, check out for 4 and check out where 2 is. What you had as 3, 9 will interchange and becomes 9, 3. What you had as 4, 16, it interchanges, becomes 16 and 4. What you had as 5 and 25, it will interchange, it becomes 25 and 5. Kindly let me know whether that is okay. Up to where we are now. Is that okay? Where we are now? Uh-huh. Okay, now that is very okay. Now, after doing so, you go on and plot these points here when they reflect. So you plot them and then you'll find something going, it can look like this, something like that. So it will look like that. And now that one will be your graph for reflection. I've said roots. When do we not to do that? No, roots, the line y is equal to x is the reflection for all the functions. As long as it is a function and you are going to reflect it, this is always the reflection line. Anything concerning reflection of a function to get an inverse. In other words, let me put it clear. When a function is reflected, to get its inverse, it is always y is equal to x. No matter the function they have given you, as long as you are obtaining the inverse of any function, it is always along the line y is equal to x. Let me hope that is okay, Lutz. Okay, let me pick one hand. Yes. Uh, for it, the moment they tell you, oh, Molindwa, you can unmute.
Good morning, teacher.
Good morning.
Teacher, I'm asking, we draw this line y is equal to x when it is dotted.
Yeah, you can draw it when it is dotted.
What about the second curve?
The second curve, you can as well use dotted to distinguish it from the one that is inverse.
Teacher, the other question is, on this composite fraction you have given to us, you have said f in bracket x, you draw another box, g is g x. So you say that g x is the input. So what about on the second number you make fx as an input?
I've not gotten your question.
Or on the first example you have given to us, we have substituted gx in f, but in a second example we have substituted fx
Yes.
in the
Now,
G when you
one,
are told us that X is an input.
okay. Now, there are two things you need to know. In functions, when we have gf of x, it is very different from fg of x. Gf of x means f of x is the input for g. F of g means g is the input for f. So these are totally different. Gf is not the same as fg. Yeah. So when we say Murindo Raban is not the same as Raban Murindo. So those are totally different things. So here there is no commutativity. Yeah, when it comes to functions. Okay. Now, I was still telling you. Now, where does this line come from? You remember very well when you are getting the inverse of functions, or whenever you are finding the inverse of the functions, always you interchange. You say x is equal to y and y is equal to x. When you are finding the inverse of a function, I don't know that people remember that. So if you are doing so, then that's where it comes from. So for whatever inverse you are finding for any function, always this is the reflection line, this is the mirror line. And that's why in the calculations, always you interchange. Your y becomes the x and your x becomes the y. Let me hope that is okay now to everyone. Are we on the same page now? Okay, okay, yes, yes. Okay, now so that will be your answer, and then after you locate that this is your G inverse of X. So that is how you reflect. Now, in case it was calculation, remember sometimes it can be calculation. Now, in calculation, you remember what you do. In case you have your function G of X is equal to X squared, always you interchange. What is your x? You can call it, you call this your x, and then you call this your y squared. And always your task is to make y the subject. So you get the square root, get a square root. So you get root of x is equal to y. And then after you conclude that my g inverse of x is equal to root of x. Yeah. So I think now we are good to start on some work. Now, we have this is our first scenario to first remind us the different things. They are telling us that we have a certain tourist in USA is planning to visit the following places in Africa. Next month, the tourist has highlighted the following places on the map of Africa. These include South Africa, Burundi, Kampala, Dodoma, Accra, Bujumbura, Nairobi, Ghana, Johannesburg, and the rest. As a student of Senior 4, list the places in the domain set and two, the range set. Now, this one will require to critically think and ask yourself, what am I going to put in the domain and what am I going to put in the range of the set? Can someone raise up the hand maybe and you share with us what you think you're going to put in the domain and what you're going to put in the range? Yes, Chirab.
I think for the domain, we're going to have Africa. Then in the range set, we're going to have, I think, countries in Africa.
Okay, good. Chirabo, don't go off. Let me ask Molindwa.
Teacher, we are going to put countries in the domain and you put capital cities in the range.
Okay, thank you. Chirabo, is it the same idea now? Okay, thank you, Mulindwa.
But thank you very much. I've now
Okay,
seen the Accra and yeah.
okay, okay. Chirabo, you tell us now. Now, here we are going to have the domain as our set of the countries. So, what are we going to have?
South Africa,
South Africa,
Burundi,
Burundi,
Ghana,
Ghana,
Tanzania,
Tanzania,
Uganda,
Uganda,
Kenya,
Kenya,
Egypt,
Egypt,
and Rwanda.
and Rwanda. Very good. Then what are we going to have in our range?
We're going to have Burumbuja.
Bujo? Which one?
Yeah,
Bujumbura.
yeah, Bujumbura, so sorry. Nairobi,
Nairobi,
Johannesburg,
Johannesburg,
Accra,
Accra,
Dodoma,
Dodoma,
Kampala,
Kampala,
Cairo,
Cairo,
Kigali. Yeah,
Kigali.
I think those are it.
Okay, thank you. So now that's how you state your domain, and that's how you set your range. So here we expect that in your domain you'll have the countries because those are the inputs, and then the range will have the outputs. So these are the capital cities. Then when they ask what is the relation between the domain and the range, what relation do we have there? Okay. Yes, Chilabo, I'm seeing your hand is already up.
And between the domain and the range is the fact that for every country, there is a capital city for it.
Okay, capital cities and the countries. Very good. Okay, so here your relation is the countries and their capital cities. Okay, then the next one, part C, required us to help the tourists sort the places by using an arrow diagram. Now, when we are using an arrow diagram, yes, Molindo?
I wanted to give the answer
Okay,
on part C.
okay.
So we are going to put here our domain as the countries we have stated here above in domain. Where is we put here South Africa,
Okay.
Burundi, Ghana, Tanzania, Uganda, Kenya, Egypt, Rwanda. So, and we're going to come here and we draw our range. South Africa is Johannesburg.
South Africa is Johannesburg.
Johannesburg.
Then Burundi.
Bujumbura, Accra,
Ghana.
Accra,
Mhm.
Dodoma, Kampala, Nairobi, Cairo, and Kigali.
Okay.
So, and we come and do the arrow diagrams to meet the countries and the capital city. And you put direction. Yeah.
Okay. Thank you.
Welcome, teacher.
Yeah. So that's how you can draw your arrow diagram. So that's how you draw your arrow diagram. Sometimes it is okay. If you want to use these brackets here, it is okay, the circle, or you use these ones. Any type is very fine. Then when they ask, describe the type of mapping the arrow diagram in C above. Which type of mapping is that? One-to-one mapping. Very
One to one.
good. So one-to-one mapping. So this is a one-to-one mapping because every element in the domain maps to exactly one element in the range. Now, if they asked, does it qualify to be a function or not? What would be our answer? Does it qualify to be a function? Yes or not? Yes, it is a function. And what could be our reason? What could be the reason for it to be a function? Okay, yes, Mugisa.
Yes, good morning, sir.
Good morning.
Sir, my phone it got off when you were describing the relationship between the domain and the range. I'm requesting you to help me on how you have stated that relationship between domain and the range.
Okay, the relation is between countries and their capital cities. Countries and their capital cities.
Okay, sir.
Okay. Okay. So, that is it. So I think, yes, Marita.
Morning, sir.
Good morning.
Chef said anyone to give a reason. The
Yes.
reason for it to function is because it only has one input. Like,
Sure.
yeah, it is not sharing or it's not many to one. It only has one.
Okay. Okay. So, Marita, always what
Yes.
you need to focus on is the range or the output. That's what determines whether it is a function or not. So you remind us, if it is a function, what is so special about the output?
It is only like one.
Very good. So it must have one.
Out.
Perfect. Yes. It must always have one output. Yes. Is that fine?
Yes, teacher.
Yes. So it must always have one output. Okay. So that is how we approach that number. Okay, now we go to the next one. I want everyone to first read through that. Okay. Let me hope we have finished read through. Okay. Now, after doing so, one thing on the arrow diagram I've not told you is that please do not forget to put those arrows. They are very important. Now, they have told us that we have a company that manufactures and sells uh, handmade candles. The daily production cost in dollars is modeled by the function where P is the number of candles produced each day. Due to a new marketing strategy, the daily production output increases over time according to the function. where T is the number of days since the marketing strategy was implemented. And now here they're asking us that find the composite function CP into T that represents the daily production. Now here, I wanted to show you that always do not cram that your functions are supposed to be FG. No, they can be in any variables as long as it really applies. So now here we are going to come and ask ourselves, how do we get the first function? We say that when they ask us CP into T, this one is always the input for our second function of C. So I'm going to first come and I say this is C. Then what is P? P into T is the same as 3T plus 2. Now, in the function of CP, wherever there is P, I'm going to put 3T plus 2. So I'm going now to come here and say that my function was 5. Then where there is P, here is where I'm going to put, but it is squared. So I'll have 3T plus 2 squared, then plus 10. Kindly let me know whether we're on the same page. Abigail has said no. Okay, I don't know. Abby, can you unmute and maybe you share? I want to first know exactly.
So I was requesting that you repeat, like I wasn't just doing this question. Can you
Okay,
review?
I repeat. We have said that we have two functions. We have C into P, which is 5P squared plus 10. Then we have the second one, which is P into T, which is 3T plus 2. We say that in functions, when we are finding CP into T, when we are finding two composite functions, or when we are finding the composite function, always in functions, we have what we call the input. Now the input is here, and then from this input, we have what you call the output. Now, the input for this function is your P of t. But this P of t is going to be feeding C of P. So the first, what you do, your input is P. So you get your P and then you put it into C. Then at the end, what you get is your output, which will be CP into T. So we are going to get P of T and put it into C of P. Then the answer we get is going to be our composite function. Now, for here, we have P of T here. Now, this P of T, we are going to replace it here where there is P. But this P is squared. So the whole of our function, we are going to have 5 P of T, but everything squared, then plus 10. But where there is P of T, we are going to put 3T plus 2. Now we are going to start. So we shall say that C P of T will equal to C. But what is P of T? This one alone. That one is given by 3T plus 2. Now from there, we go in our function of C. Where there is P, we replace it with what P was. So here I will come and I say now 5 into 3T plus 2 squared, then plus 10. Hope that is okay, people. Is that fine? Now, to everyone. Now, if that is very okay, I'm going to come and I first expand this. Now, when I'm expanding, allow me to do the side work. It will be 3T plus 2, 3T plus 2, since it is multiplied twice. So when I come, we know that this 3T multiplies everything. So you say 3T into 3T plus 2, then plus 2 into 3T plus 2. So you open your brackets, 3T times 3T, which gives you 9T squared, plus 3T times 2, which gives you 6T, plus 2 times 50, which gives you 60, plus 2 times 2, which gives you 4. Now from there, we shall have our 9t squared plus 6 plus 6, which gives us the 12t, then plus 4. So that is what we are going to replace here. So we shall come here and say now this is 5 into 9t squared plus the 12t plus the 4, then plus the 10. So now we open up the brackets. We say 9 times 5, which is 45 squared, plus 5 times 12, which is the 630, plus 5 times 4, which gives you the 20, then plus 10. So from there, we are going to open up and now have 45t squared plus 630, then plus 30. So that is your CP of t. Okay, so that is your first one for part 1. Kindly let me know whether now it is clear to everyone. Now, I'm not saying people who have got used to X, you need to add just, okay, people are saying it is now clear. Now, after obtaining that, we can go on and go to the part 2, which says that calculate the daily production cost for 7 days after the marketing strategy starts. Remember, your T was the one representing the number of days. Now, what are we going to do? I want everyone here to come and substitute for us 7. So you're going to come and say now, my CP, you're going to come here and say now, my CP of 7 is equal to 45 times 7 squared plus 60 times 7 plus 30. Can you come up with the answer? Can you come up with the answer? Come up with your answer. Thank you, Hunter. Hunter has 2655. Good. 2655. Milton, Emerson. Okay. Hope everyone has those 2 answers. Okay. Okay. Hope that is very okay to everyone. When you put here in your calc, people are getting 2655. Okay. Yes, Chilabo?
Just wanted to add on that I think it's also important to put the units that they gave us, which was in dollars, because most people will put shillings. So I think we should remember it was in dollars as well.
Wow, wow, wow. Perfect, perfect. These are dollars, right? Yes.
Yes, teacher.
Thank you, Chirao. That is very, very important. That is very important. So do not forget this. You may put shillings. Okay, thank you for the reminder. So that's how you had to do it. The other alternative, in case they had not asked us to calculate the composite function, the other manual way you could do it, the other manual way, let me call it the manual way. Now let me say for part 2, the manual way was you first get P of t, which is 3t plus 2. Now, this was 7 days. So you say P, when we have 7, this will be 3 times 7 plus 2. So this will give us 21 plus 2, which will give us 23. Now, after getting 23, to get the cost, you come back here and say now my cost of 23 will equal to 5 times the 23 squared plus 10. So still, you get the $2,655. Yeah, that would have been the other alternative if they had not told us to use the composite function. Let me hope it is now clear to everyone. Are we good to continue? Are we good to continue? Okay. Okay, people are saying we are good to continue. Okay. Can you quickly do for me this one on your own? Quickly. After place your answer in the chat. Quickly. We are doing this on our own. Don't write the question, just do, just do. Okay. When you finish, feel free to drop your answer in the chat. Okay. Okay, according to one of the answers I'm seeing in the chat. Abby, you check out. There is something you are forgetting. There is something you are forgetting. Hey. According to Hunter. Abby, there is something you have forgotten to multiply and it is costing you heavily. There is some 100 you are forgetting. Okay, according to the charts, people are coming up with 400x squared plus 400x plus 104. Yes, Chilavo. And that's what people are coming up with. So let's strive to come up with that also. And then according to part 2. People are coming up with 12104. I don't know whether that was Ugandan shillings or what. So kindly, yeah, in case you are getting stuck, you can let us know. You can let us know. Oh, people are still stuck. Anyone? Hunter. Where is Hunter? Hunter, can you unmute? Hunter? Hunter.
Yes, sir.
Okay, Hunter. But what's your real name? Okay, but it is okay, no worries. Okay, Hunter, take us through.
Part A of
Mm,
FG into brackets X is
mm,
equals to F into brackets to X plus 1.
okay.
And then we get the function of Fx equals to 100 x squared plus 4. So we replace 2x plus 1 where x is.
Mm,
To be 100 into brackets 2x plus 1 close brackets squared plus 4. Then that is 2x plus 1, 2x plus 1 squared gives us 4x squared plus 4x plus 1. So it will be 100 into brackets 4x squared plus 4x plus 1 plus 4. Going to give us 400x squared plus 400x plus 100 plus 4. Then it will give us 400x squared plus 400x plus 104.
okay, thank you, Hunter. Then part B.
Okay. So part B will be, since they want us to find a profit 5 days after, so we shall replace 5 where x is in our FG and X function. It will be 400x squared plus 400x
Okay.
plus 400x plus 104. That is 400 times 5x squared plus 400 times 5 plus 104. Then it will be, the total amount will be 12,104.
Okay. Thank you, Hunter. Okay.
Welcome.
Yes. Yes, Virginia. Virginia, are you able to unmute? Virginia? Virginia, you can unmute. Oh, I think I'm failing to get Magezi. Magezi, I'm failing to get you. Unmute. Magezi. Okay. Okay. So I failed to get Virginia. Yeah. Okay. We have another one here. I want us to read through. Oh, okay, Virginia. Okay, now let me first make some clarification here. I know people are confused with X here using the same variables, because you cannot, at first was representing the number of crates, and then here it was representing the number of days. So here, just because I think we use the same X's, but at the back of the mind, that the idea was about here we would have used another, let me say another letter for the two. So sorry about using the same letters. Yeah, but the idea is the same like the previous one. Yeah. Okay, let me hope it is now clear. So here it was better we use different what letters, such that you do not get what confused. So we would have used two different letters. So here the best letter, let me say, if here I had used let me say P, maybe something, and then here I use P. Yeah, but the idea is the same. What I wanted was you to be able to calculate the functions. Okay. Now we are on this one. We are on this one. I want you to read through. I don't know that now Virginia it is okay.
Okay, sorry, teacher. I needed to fix settings. So for the part A, where the person who explained got 400x plus 400x squared plus 400x plus 4. And how did they get 400x?
Oh,
Like,
okay. Okay.
yeah,
Did you get this part of squaring
squaring.
here?
Like, did I understand it? Yes, teacher.
Okay. So when we square 2x plus 1 squared, what do we get, Virginia?
2x plus 1 squared. I got, okay. As getting 2x squared itself and then 1 squared and then getting 4x squared plus 4. So sorry,
Okay.
plus 1.
Okay.
Thank you.
Okay. Okay, we come back here. We come back here. So read through this and then we start. So after reading through, then we shall start on it. So they have told us that after moving to his new home with his family, Mr. Ocheng was informed that his monthly water bill would consist of a fixed service fee of 34,000 plus a variable charge based on the number of units of water consumed. In the first month, the family used 4 units and received a bill of this. The following month, they used 10 units and were billed this. Mr. Ocheng wants to understand how the bill is calculated and the plans his budget and such that he can plan his budget wisely. Then the first part, develop a linear function that models the total water bill in terms of the number of units you used. Now, what does it mean? Those who pay for, I don't know that at home you get a chance to pay for Yaka. An example, I can use Yaka as an example at home. When it comes to Yaka, there is always a tax that you pay every month. I think it is, I don't know the exact amount, but I think what is 3,000 or something like that. That every month before you pay for your units, they charge you that tax. Now that tax is what we call the fixed. For it is fixed. Everyone that pays every month, you pay in for that amount. Another example is that when you go in hospital to see the doctors, even before you see, they will tell you that the consultation fee, before even you mention your problems, you have to first pay some consultation fee. I don't know how much it is, or it is 10K. Then that's when you go to the doctor, and then they will start charging you at different things that you have problems with your eyes. That service costs this. You have maybe problem with the stomach. This is how much they will charge you. So they start charging you everything. So service fee is always constant for that particular service you go in for. So in order for us to be able to obtain the total cost, we shall say that total cost or total water bill will equal to the service fee, which is the fixed service fee, plus the variable charge. Members, is that fine? Could that be fine to everyone in the chat? Uh, I don't know whether it is okay or not. That first step. Then I'm going to since they have told me to develop a function, I'm going to say that let the total water bill, let the total water bill be, let me say, I'm going to use T. Then here, oh no, in fact, they told you C. In the question, they wanted you to use C. And then the number of units, they said U. And then the number of units, B, U. So the total bill is going to be C. Then since we are writing our function, it's going to be in terms of the units, is equal to the fixed amount, which is 3500, plus the variable charge. Now, the variable charge will depend. One, we don't know the charge, the cost per unit charge. So here, the cost per unit charge. So it's going to be the number of units times how much each unit costs, which we can call U stands for the number of units. Then I'm going to put here a letter. Let me say I can put, let me put X to represent the unit per charge. So here I will say the charge per unit. Charge per unit B X. So here I will say C of U will equal to 3500 plus UX. Members, are we still on the same page on that? Are we on the same page? Some yeah, others no. I repeat. I'm going to repeat. I'm going to repeat. They are telling us that we need to find the total cost of the bill. Let me use the hospital. When you go to the hospital to buy, or when you go to hospital for medication, you have to pay for the consultation fee first. Consultation, let me say 10,000. Then after paying for the consultation fee, there is other things you have to pay for before you deliver, because here you're going to just see the doctor. Then after describing what you are suffering from, then your total cost will be the 10,000 you paid, then plus the other services you received. Another example, sometimes when we call people to work for us at home, they will tell you that before you give me your call, first pay my 10,000. Then they will tell you that every hour I'm going to spend at your home, you must pay me 50,000. So that means you will say the 50,000 per hour times the time he has spent there. That is the meaning. So to get the total cost of the water bill, I'll get the 3,500, the fixed amount. This is like the tax you pay. Then times the number of units that you are going to use. Then times what is the cost per unit charge. That if the unit is going in for 3,000 and I'm to use 5 units, that means I'll have here 15,000, then plus the tax, which is 3,500. I don't know whether now it is clear or not yet. Is it okay now? Okay, I'm seeing very many hands raised. Let me first speak on. Yes, 7.
Excuse me, teacher.
Yes.
For the
Yes.
price of 1 unit, I think, in my opinion, we can calculate that, and then whereby they have told us 4 units, they pay a bill of 15,500 and they have a fixed service of 3,500. So why don't we subtract the fixed service and divide? We shall get the answer as 3,000. And if you also do it for the 30,500, you still get answer should be 3,500 plus.
Yes. 7, you are very correct. Yes. Okay. So 7, I think we lost you. Okay. So now what 7 is saying is exactly what we are going also to continue doing. Then, but here I was developing the function we are going to use, since they told us to develop a linear function. Now this is the function we have developed. Now after developing, we need to substitute the unknowns, because they gave you the condition that when you have 4 units, then here you are going to say that when u is equal to 4, then the bill, which is the cost, was 15,500. So I'm going to come and substitute. Where we have C, I'll put 1,5,500 is equal to 3,500 plus the number of units, which are 4, then times x. Then here I solve this equation. So I will say 15500 minus 3500 will equal to the 4x. So when I reach there, I'm going to substitute 15500 minus the 3500, 15500 minus the 3500, it will give us 12000 equals to 4x. Since now we are interested in x, I will divide by 4. I will divide by 4. So when I divide by 4, I'm going to get 3,000 is equal to x. So when you test it using the second, for the following month, still you're going to get the same answer of 3,000. So you can as well do it here to show that x is consistent for all. So when I come here, I'll have 3,500 equals to the 3,500 plus the 10x. So when that one comes this side, it will be 3,500 minus the 3,500 is equal to 10x. Now, when you subtract, you'll get 30,000 equaling to 10x. So when you divide by 10, you are getting 3,000 is equal to x. Now, why are we substituting 2 times? Is to check out whether our x is constant for all. Otherwise, if the x was different, then it means that here we shall not have formed a linear function. But now since we have got our x constant, our x is 3000 for the first, 3000 for the second, it means it is the constant. So that means that each unit is charged at 3000. So after getting the x, I'm going to come here in my equation, and now I substitute again and I say C of u will equal to 3500, then plus, where there is x, I put 3000. So I write 3000 u, like that. I don't know whether 7, it is okay now. 7?
Yes, teacher.
Okay. Yeah. Okay. But your approach is also very fine, eh? Your approach is very fine. You can first do it that way. You get the cost per unit, and then you continue to develop the function. Okay. Okay. Let me... Yes, Mulindwa?
Teacher, linear function is not the same as a function, or they are the difference.
A linear function, it means that it gives you like a straight line. Okay. So it means it gives you a straight line. Okay. Members, are we good to continue to part B? Use the function to determine the cost per unit of water and predict the bill. We have the cost per unit of water and predict the bill if the family uses 15 units in a month. So we have used the function to determine the cost per unit of water. We have determined the cost per unit of water, which is 3000. Then they're asking us to determine how much money we shall spend on 15 units. So can everyone now find out how much money shall we spend on that? Okay, Chirao has got 48500. Okay, everyone. Natalie is getting, Hunter is there, 7. Is everyone getting there? Okay, are getting there. So when they tell us to get the units, next time they can as well tell you to predict the number of units someone would have. Someone like they can give you the total amount of money, and then they tell you the kind of units for you to obtain the number of units for that particular person. So let me hope that is okay to everyone. Okay, so just substitute and then get the answer. Okay, so here I expect you to come and say C of 15 will equal to 3500, then plus 3000, then times 15. Then you come up with the total amount. Oh, that one is done. Okay, we have another one here. Read through it. Okay, let me hope now we have read through the item. Let me hope we have read through the item. Now, when you read through the item, they told you that Melissa is watching a video on her phone. After 5 minutes, she notices her phone battery has dropped to 90%. The battery is draining at a constant rate. Now, this word here is very important. A constant rate. That means that the rate at which everything is changing is the same. And she expects it will take a total of 50 minutes from full charge until the battery is completely empty if she continues watching the video without stopping. Now, so this is without stopping here. At the same time, Melissa is planning to buy a new phone during the upcoming festive season. Her dream phone costs 500,000. The shop offers this and this. Now, the first part here asks you that find a function f of t that models the battery percentage remaining t minutes after Melissa starts watching the video, assuming the battery drains at a constant rate. Now, since the rate is constant, this is where now we apply our knowledge of one. We are going to apply the knowledge of gradient, because it is through gradient where we get constant rates. Now, how are we going to do it? Now, one, we have two approaches we can approach this number. They have told us that I'm going to model it. I'm going to first write it in this form, whereby I have the time and I have the percentage. I can write it like that. I have the time, I have the percentage. Now, they told us that she noticed Abbott has dropped to 90% after 5 minutes. So it means that when the time is 5 minutes, the percentage the battery is at is 90. Now, you tell me through the charts, if it is 5 minutes, the battery is at 90. You tell me, I want us now to do at when the time is 0, at what percentage is the battery? At what percentage is the battery? 100. Very good. So here it is at 100. I don't know whether people are getting it. Is everyone there? Now they're asking you that the battery is drained and she expects to take a total of it for fully charged until the battery is completely full. Now, what does it mean? Now, here we can use these 2 points here to be able to obtain our gradient. So here we are going to apply our knowledge of gradients. Hope that is okay. So we are going to apply our knowledge of gradients. So we know that now we have 2 points. We have this one can be like your x, this one can be your y. So we know that in other words, we want to establish what is that constant rate. You know very well from your gradients that y is equal to mx plus c. I'm just bringing you this side, whereby m means the constant rate is the rate at which something changes. That is your m. And c is the intercept. So we are going to find those 2 variables such that we can be able to find our function. So in other words, we are going to look out for what is our m and what is our c. Then your x is the time. So your function here of y is going to be our function. So we are going to have f of t is equal to m times the time plus the constant rate. First, let me know whether this is okay. That equation I've put down. First, let me know whether that is okay. Okay, not yet. Okay, I come. Yes, Chidabo?
Teacher, I was just requesting that you may Repeat for the y is equals to mx plus c. What the different symbols are. I never heard you, okay?
Okay. M stands for the gradient. X stands for the variable that keeps on changing. And C stands for the constant. What doesn't change is the C. Now, if we have these 2 points here, if we have these 2 points here that we have understood how to get there, and since they have mentioned that it is a constant rate, it means that it does not change every after given period of time. It is the same throughout. Now, if it is a constant rate, then here we can utilize the equation of a line to develop our function. It means that we are getting a linear function. Whenever something is constant, it means that we are getting a linear function. A linear function can be developed using the equation of a line. Now, these 2 points we have here, they are going to help us to obtain our gradient for the linear function. Anything that is linear will have a gradient. Like the same thing that has happened here for this number we have been doing about costs, that you had 3,000, this was the constant, then times the 3,000, then times x. This is a linear function. 3,000 is the gradient, is the cost per unit. Then x was the thing that changes, and this one was the service fee. So the same thing we are going to do here when we are developing. In other words, even for this previous number we were doing here, this number here, we could have used the same. We could have said 4 units, they were charging this. Then also the 10 units here, it is now 33500. Now, what is this constant rate, which is the C? From here, that y is equal to mx plus c. So we could get this m here by using this knowledge. So you could say m is equal to y2 minus y1 out of x2 minus x1, which will give us 155, let me say, which will give us this one minus this, then this out of this. So you end up with the same answer. So that is the other alternative we could have used. I don't know that people are getting the idea. Are people getting the idea?
Yes, teacher.
Yes, so that is the other alternative. So someone could come here and say, this is my y2, this is my y1. This is my x2, this is my x1. So you do 33500 minus 1500 divide by 10 minus 4. So when you subtract 33500 minus 15500, you'll get here 18,000 divided by 6, which will still give you 3,000. So this is the alternative. Whenever something is linear, it means that we can develop the equation using the equation of a line. Yes, the y values, yes, you make the y values the bigger always, yeah. I don't know whether now it is okay. Let me know through the chat whether it is okay. Is it fine? Okay, okay, okay. It is okay now. So now I can come back here. Now, when I come back here at this point here, I'm going to do the same. So I'm going to say I have my 2 points. This one can be my y2. Then this one can be my x2. This one can be my y1, then this one can be my x1. So the first thing we are going to get is the gradient. So we shall say y2 minus y1 out of x2 minus x1. So our y2 is 100 minus y1, which is 90, divided by x2, which is 0, minus x1, which is 5. So we shall end up with 100 minus 90 gives us, that is 10, divided by negative 5. So our gradient will equal to negative 2. Kindly let me know whether that is very okay. Is that fine to everyone? Good. Now, after getting that, we are going to come to our function here, and we say now, our function, our linear function, is equal to mt plus c. Now, what is our m? Our m is a gradient, but we have got -2. Now, once you have a negative gradient means something is reducing, something is decreasing. A positive gradient means something is increasing. And here for our question, since the battery is reducing, that's why we have a negative. So here we shall come and say now, we have f of t equals to -2t plus c. But now your question or your task is to find out what is this c. So to find c, use any of the points. So I can decide to use 0 and 100. So when this is your x, this is your y. But now for this case round, your x, what is your x? Is your t. What is your y? Is your f of t. I don't know that makes sense. I don't know whether we are on the same page. So if that is okay, where there is f, I'm going to put 100 is equal to -2 times 0 plus c. So here I'll remain with 100 is equal to c. So that means that my function f of t is going to be -2t. Where there is c, it's going to be 100. And this is my linear function model. Has that clicked? I don't know that has clicked. Lutz, you can unmute and first tell me where the problem is.
Yeah, I don't understand that part where x is t and y is f of t.
You have not understood where?
Down there,
Is
x
this
is t
okay?
and
Was this part
yes,
fine? Then
yes,
here,
yes,
now our equation is always in this form, right?
yes,
And when you compare this and this, you notice that y is where there is f of t. You compare x is in the position where there is t.
yes,
Are you getting it?
yes.
Yeah, so where there is y is your f of t. So it is this 100. Then where there is x is your t, and here it is 0.
So when you're using the linear equation for calculating anything, y always has to be the bigger value.
Yes, like y is the bigger than the x. No, like, okay, you reason it out basing on time. Like the variable that changes is what is your x. You look at what is that one that is going to keep on changing after a given period of time. Like one is an independent, can I use independent and another one is dependent? That for us to get y, we must have x. So the one that depends on the other is the y. The one that doesn't, I don't know that you're getting it.
I am.
So the one that, because here, for us to get y, we must have x. So the independent here is the x. So the independent variable is what you let to be your x. Then y becomes the dependent. Is it fine?
Yes.
Okay. Okay. Yes, Mulindwa?
Teacher, for me, I request to make a more elaboration on this equation that y is equal to mx plus c, and you have formed this equation. You explain that equation, teacher.
No, like y is equal to mx is an equation, is a linear equation. This is the equation for a linear model. We said m stands for the gradient, the rate at which something keeps on changing. That is the m. Then x stands for that variable that it stands for the independent variable in simple terms. Then c is the constant. Then y is the dependent variable. So in your function here, our m is the rate at which this battery drops. Now, according to our explanation here, it means that every after a minute, the rate at which the battery is dropping is 2. And I've said the negative means that it is decreasing. There is a decrease. I don't know that you have got it, not yet.
You have not. For me, I'm asking you. This f of t is equal to m of t to plus c. How have you?
Are you seeing this one up here? Y is equal to mx plus c. C is the same down here, right? M is the same down here, right?
Yes.
Now, what has changed is that in our question, we don't have x, but instead we have the time. So where there is x, we have replaced it with time. Is that okay?
Yes, teacher.
We don't have y because they have told us to use f of t. So f of t is our y.
Yes, teacher.
So we have just replaced. Okay. Olive?
Yes, excuse me, sir.
Yes.
Yeah, I'm saying to get this equation, the final equation, which is f of
I don't know, I'm not getting you. Probably your network.
Negative 2t plus 100. What I'm asking,
I'm not
I'm
getting you.
saying,
yes.
I'm saying that in order for us to get f of t equals to negative 2t plus 1.
Oh no, your network. Maybe type in the chat.
That to get f of t equals to negative 2t plus 100, you have used these points of 0 and then 100.
Now, whatever point you use, you'll get the same answer. Let me hope that is the question. Even if you had used 5 and 90, still this would have been your t and this would have been your f of t. So when you substitute here, you'd have had 90 is equal to negative 2 times 5 plus c. So this would be 90 is equal to negative 10 plus c. When you take the 10 this side becomes 10 is equal to c. So still your c would have been 100. So for whatever coordinate you choose, you get the same value for c. It doesn't matter which point you have chosen. So whatever, you get the same. Yes, Marita.
So morning once again.
Morning.
Get my case is why if we are substituting and we've gotten like f into t is equal to mt plus c. We have understood, but why don't we why don't we be like f into, because we have t, like we have t as 0, we have chosen 0. Why don't you come here and substitute the ft, like with the t, why don't you substitute it with the 0?
That we have substituted the t as 0 here.
No, like this side of the
Where?
ft.
Here.
F, yeah, like here.
It's doing like this.
Yes.
It is okay, but now you need to know that f of 0 is 100 is equal to c.
Okay.
It is very fine. Okay. Okay, so now this is your function for the first part here. So this is the function that you'd have. Then they asked, what is the constant rate at which Melissa's battery drains. Yes, what is the constant rate at which Melissa's battery drains? So now, can someone put for us the constant rate? What is that constant rate? Okay, now, constant rate. The constant rate. So from the chart, yes. So here for part B, the constant rate at which it is the gradient. Gradient is the one that gives us the constant rate, members, this one here. So here the constant rate would have said m is equal to -2. But being, so the constant rate here is m is equal to -2. But you don't stop at that point. And then you go on and say, this means that the battery drains at 2% per minute. So here you would say, this means that the battery drains at 2% per minute. So that means after a minute, 2% goes off, 2% goes off, 2% goes off. That is the meaning. It means that the battery drains at 2% per minute. I don't know whether that is clear, members. The constant rate is the gradient. They are asking at what rate does the battery drain? That means that, remember at first it was 100. That means that after a minute, it will be 98. After a minute, it will be 96. After a minute, it is 94. After a minute, it will be 92. After a minute, it will be 90. And when you check out here very well, you notice that they told you that within 5 minutes, the battery had dropped to 90. So this is 1 minute, 2, 3, 4, 5. So at what rate? Between 198, that constant rate at which the battery drains. I don't know whether now it is okay, Marita. You look at what percentage does the battery reduce every after minute. Hope it is okay now. So the constant rate is always your gradient. So you can say that the battery drains at 2% per minute. Next time they'll ask you, okay. Hope it is fine to everyone. Those who are saying no, hope that is okay. Okay, very good. Okay, then the next one, they asked us that using the function, calculate the battery percentage after 30 minutes of watching the video. So that means you are going to come and use this function we have got and find out after 30 minutes what battery percentage would have remained. So can everyone at least try that? Can everyone try that? Okay, through the chat, people are getting 40%. Very good. Do not forget to write the 40%. So here people are coming up with 40%. Very good. Yeah. Hope now we are on the same page. Now we are going to continue. Hope everyone is getting the 40. 40%, dear members, those who have not gotten it, you just come here and say f of 30 will equal to negative 2 times 30, then plus 100. So this will be negative 60 plus 100, and we shall have remained with 40%. Okay. From there, we are going to continue. We are going to continue and come to the last part, part D. Now, part D told us that Melissa is planning to buy a new phone. This part here. Melissa is planning to buy a new phone during the upcoming festive season. Her dream phone costs 500,000. The shop offers a 15% discount for customers who pay in cash. In cash. Then they went on and they told us that additionally, being a loyal customer is that someone who has been maybe purchasing from that very well. So Melissa is offered an extra 5% discount on the already reduced price. Now, what are you going to say? Now, here, they're asking us to find that function that Melissa can use to find the final price. That means when they tell us to form a function, they want us to form one function. Remember, we have two things here. Melissa was first given the first discount. I'm going to say this is the first discount. Then after that, she was given a second discount. Now, what do you need to remember? If she was given the first discount as 15%, you members through the chat tell me what percentage is Melissa going to pay for the first discount? What percentage? Aha, very good. Is everyone saying that? Is everyone saying that? Very good. So I'm going to I'm going to say that let the original price of the phone be X. Now I'm going to say first discount, and I'm going to say first discount for the first discount. And please show how you are getting the first discount. So the first discount we have said to be 100 minus they gave her 15%, which will be 85%. Now 85% means 85 out of 100. So now I'm going to write my function. So I'm going to write it in form of f. I will say f of x will be now 85 out of 100, which is going to be 85 out of 100 times the original price. Now, this is the price that she was supposed to pay for the first 15%, which we can write as 0.850x. This is the first discount. Kindly let me know whether that is clear to everyone. The first function we have formed. Is the first function okay? Okay, Mugisa says yes. Yeah, Hunter says yes, Milton says yes. Now, good. Now we go to the second part. Loyal customer. They have told that Melissa is a loyal customer. Now, being a loyal customer is offered an extra 5% on the already reduced price. Through the chat, tell me what percentage have they reduced for Melissa? 5%. So which percentage shall we have? Very good. So now being a loyal customer, it means now we shall say 100 minus the 5, which now will be 95%. Not so? That means that because here now, when you look at this, because they want us to find final price. The final price for the commodity. So it will be 95%. I don't know that that is okay to everyone. So can we form the second function to show this second function of the for being the loyal customer? Can you form that function and put it for me in the chat? I want people to first put for me that function in the chat for being a loyal customer. And that one, we are going to call it G of X. That one, no, the first one we called it F. I don't know that it was F. The second one, let's call it G of X. People have started to give in their answers. So this one will be 0. It will be 95 out of 100 times X. So our G of X is going to be 0.95x. Members, is that fine? From the chat, kindly let me know whether that step is also very okay. Okay, people are saying, Hunter said, yeah. Now, how do we get the reduction, the final function? Now, the final function is going to be our function fg of x. So we are going to find out what is our combined function. I don't know that that is okay. Now, I want to explain something on functions. On functions, when we write fg, it means that we apply g first and then f. That is the meaning. When I write, so I want to put here two things and people tell me fg and gf of x. I repeat, when I write fg means apply g first followed by f. That is the meaning. When I write gf, it means that apply f first followed by g. Now you tell me through the chat, what are we going to calculate here? Is it fg, gf? I want to see people. What are we going to find? Very good. So we are going to find GF because they applied F first followed by G. So we are going to find GF of X. So I'm going to come here. I'm going to come here and say our GF of X will equal to G. Then what was our F? Our F was 0.85. So I'll say 0.85x. Now, in our function of G, where there is x, we shall put that. Remember, our function G of x is given by 0.95x. So when we come here, where there is this x is where we put that one. So we shall come and say GF of x will equal to 0.95 times 0.85x. So when you multiply, so when you multiply, we end up with 0.8075x. And now this is our composite functions. Now, after getting your composite function, that was the first thing they wanted you to get. Form a function that Melissa can use to find both discounts. So in other words, they were asking for a composite function. Now from there, then use your function to calculate the final price. Remember, we said that X represents the original price of the phone. So I'm going to come here and say now, when I have GF of 500,000, what shall we have? We shall have 0.8075 times the 500,000. And how much will she pay for the phone? So she will pay 403,750. Then you respond back that Melissa will pay shillings. Since you used UGX here, you must also use your UGX. So you say Melissa would pay 403,050 shillings. So that is what you have to do. Now, I know some of you are asking, what if when do we know that if it is GF of f of g? I repeat, I've said that f of g means that you did g first followed by f. When we write GF, it means F first followed by G. Here you can use the knowledge. You can use which knowledge? You can use your knowledge. You can use your knowledge. If you remember, if you were around when we are covering transformations. In transformations, I told you that when we write T2, T1, this one means T1 was applied before T2. So when I have F and I have G, here it means I write GF. It means F followed by G. That is the meaning. Yeah, so you can pick an idea from that. So here, I know some of you say, what if we had done it using the manual way without functions? Remember, here, this one, you can use it just to prove your answer. Remember, initially, it was 85%. That means it would have been 85 out of 100 times the 500,000. So when you get that one, 85 divided by 100 times the 500,000, that means she would pay 425,000. Then they told that they reduced again on this already reduced price. So it means that now the 5%, when you remove the 5%, it becomes 95 out of 100, then times this amount. So that one times the 95 divided by 100, you end up with 403,750, which is the same amount we have obtained. Hope it is clear. Can the answers be different? No, the answers are always the same. No, like here now, you remember we said f of g is not the same as gf. So these ones are totally different. Yeah, Mugisa. Much as for such a case, for this case, you will get the same answer. But know it that it is not the same. Hey, now someone saying, if the functions refuse, can I do that? I will say, you'll have your answer correct, but the approach you have used is not the best approach. So here you'll conclude that Melissa would pay 403,750 shillings and save, even you can even put how much she saves to be an extraordinary child. Okay. Kindly let me know whether we are on the same page through the chat. No, they don't carry the same marks. If you don't use the other approach, you do not carry the same mark. What if I subtract the 5 from 85 since they already offered that? Now, remember what you are subtracting. What you can do, you can come here. Now, what that person wants to do, you can come. Now, what the person is asking, what if I subtract the 5% from 80? No, now what you want to do, you can come and say 5% of the 425,000. Then you find out how much does the 5% contribute. So you come, you do like that. So you get the 5% will be 21250. Then after getting this amount, you come and say 425,000 minus the 21250. Then you get the total amount. Hope that is okay to the person who's asking. Otherwise, you don't reduce because the 80% is not out of 100. So you can't reduce from the 80%. Hope Kilara is okay. Kilara, you can't reduce from 80 because 80 is not a full percentage. So when they reduce 5%, they have reduced from the full percentage. So if you are to reduce the 5% from this amount you had remained with. Then get the total amount, how much the 5% contributes. Then you subtract from the original. Hope Kilala that is okay. In case the question is specific, please stick to that. Now, I saw someone who was mentioning things of proportions. Now, one, at your level, at this level, or according to your syllabus, you do not do or you don't offer what we call variable proportions. You don't do those proportions. And I know your teachers might not have taught you variable proportions. Variable proportions or constant proportions were in the other old curriculum, whereby you could find f of x is equal to a constant plus the variable change. Those ones were done in the other old curriculum. But in your curriculum here, we only stop at direct and indirect proportions. Now, for you, the moment you bring in your variable proportions, you are on a wrong track. So here, the knowledge behind it should be about the equations of lines and using that linear model. Hope we have answered you. People were asking, I saw someone bring in the proportions, whether you should use proportions or whether you should use the other. If, for your case, if it is proportions, it should either be direct or indirect. Outside that, it is not part of what you are supposed to cover. So here, I do not expect you to use your knowledge of proportions, the other part. Hope I have answered you. Hey, how do I notice proportions are not equations? Now, when it comes to proportions, how do I notice proportions are not equations? Now, when it comes to equations, the moment they mention things like a constant rate, then that means you'll know that one has an idea of equations. When it comes to proportions, you read through the scenario. The scenario will direct you better. That, like, in case these proportions, you'll find words, or you'll find that I don't know, maybe things like someone can do work, a given amount of work at this particular part. Someone can do something like this. So for proportions, you read through the scenario. I don't know whether I have something. I don't know whether I can get something here on proportions. Let me see whether I can get, I don't know whether we did something on proportions. Yeah. But for it, you look at those kind of relationship between different quantities. You look at the relationship mainly between quantities. You look at the comparison they are making. Now that one will show you that now you are dealing with proportions, or you are dealing with, yeah. Let me check out for someone has mentioned that as if it was in CAMSA. Let me see. CAMSA. Let me see whether I can get that paper of CAMSA. Okay. Let me see whether I can get, someone has mentioned that as if it was in CAMSA. Maybe, let me see whether I can get it. A proportion, CAMSA. And ratios mainly and proportions are always mainly in number item ones, item ones. But all element of construct one. So I don't want to say that it's always number one, because sometimes it can change. Now, when you look at CAMSA here, they told that at the start of the harvesting season, the cooperative management team of Refugio stocked enough maize to feed this and this. for 84 days. However, in the second week, the camp received an additional 295 refugees who were transferred from another settlement. This unexpected arrival raised concern among the supply, how long the current food stock would last. Now, for such, this is where, because here you notice that the rate at which these people come in is not the same. Now, here, when you look at, you are comparing two things. You have the refugees, the number of days, and what are they doing? So what happens when you have more people coming in and the number of days? So which kind of relation do we have on the days? This the food you have, or the feeds, or let me say the food. What kind of we have? Days and the food. That maybe you can say that the more people when the people are many, or when the refugees are many, it means that the food will take less days. Or that means you will need more food. So now you need to look at that kind of relation. And now this one would drive you to that this kind of relation will mean that this one is going to lie under proportions. That more food or more days, more people, more food, and the number of days also differ. So here, this one you can apply your knowledge of proportions. So it depends. Yeah, but like I told that proportions can appear in any element of construct. So this one can appear in any element of construct. It's not that it's supposed to always only be in item 1. Proportions and ratios can appear in almost all elements of constructs. Yeah. So you need to know. Now here, you'll use your knowledge of proportions. Yes, Middleton?
Sir, in that very paper, in fact, I sent you a message in your inbox. I wanted you to give me a hint on item 2. It was linear programming, having something like fractions. So I just wanted you to give me a hint because I tried the number, but the concept doesn't come out. Yeah.
Okay, maybe when I get time, I think I'll try to draft something on this. Or I will do item 2, then I upload it.
All right. All right, thank you, sir.
But still, I don't know what it was, but now still, even when you have this what, I don't know. Okay, I'm not sure what it was about, but still, even when you find that you have that fraction into this, let me the equation. This is something you have. What you do, for you to be able to deal with it, you first remove this one here down by multiplying through by 2, such that you remain with 5x plus 2y less than or equal to 8. So don't deal with the fraction. First remove this one down by multiplying throughout by 2. Such that you don't have any fraction in the end.
Thank you, sir. But also, that is state theory is also becoming a problem because they also brought us an item on set theory having fractions.
Oh, it's still in the same pair?
Yes. About set theory.
Okay. It's still in this same paper. I think when I get time,
yes, sir.
When time allows, I think I'll look through it, and then I think I'll just do and then upload.
Yes. Okay,
This one
thank you,
here.
sir.
Okay.
Yeah,
I'll
it's
look through
down.
it.
Yeah.
Okay. As someone has told us that God's own, it's always one relation given, while for equations 2 are given. For example, women cultivated 5, how many would 7 days proportion? While equations of a line would be 2 cultivate and 5 and 3 and 7. Yeah. So yeah, that is okay. So you need to practice and then get exposed to very many items. Yes, Chidab?
Teacher, mine was just for you to elaborate more on the proportions thing of this question exactly. I really just want to see how the answer would look like and how I can relate it when I find different items on proportions.
Okay, okay, okay. I'm going to do. Yes, Mulindwa.
Morning, teacher.
Yes.
So I'm asking, there is a question you gave us yesterday in the group. Do you still remember it, teacher?
What was the question about?
It was about SADs, because I see it when they are many square roots there. I don't understand it. It was item 2. If you have it, teacher, you can give more light about it.
Okay.
Because I have seen it in very many papers, but I have not understand it.
Throw more was because I don't recall.
But it was in Teachers Association.
Because the one we did yesterday, we did one in that issue paper.
But teacher,
Yesterday we did.
but teacher,
Yes.
teacher, you send it in the group for us
Oh,
to
yes, but
practice.
that one I sent, we did the first part, second part about those things. What we did in the lesson. Okay.
Teacher,
The things we did last in
thank
the
you.
lesson. I expect you to, but that's what we did at last in the lesson. Yes, Milton?
Sir,
Yes.
in that very paper, there was an alternative. There was another number. I think it was part A in Shule. It was in paper. It was in this paper of Shule TV. There was also an alternative one, I think on number basis. Yeah, but I tried even, but the concept also refused. I even sent it in your inbox.
Okay. What was it about?
I think it was about number bases, but very confused. Yeah. Yeah, yes.
Okay, I think now number basis, still in the same paper.
Yes, Shule TV.
Okay, let me first check and I see how long that number can take. Okay, let me just check. Senior 4. Because for number basis, okay, the one for Shule.
Yes, sir.
Is an inter-class competition in which the winning class would receive a prize that was a value map of 10 presented, converted to base N, where this.
Yeah, that very one.
What was wrong with that? Which challenge?
No, I tried. Yeah, part A. I tried part A, but I failed. I failed it to come up with the answer.
Okay, I think that one also I'll get time, but I'm going to ask, I know I've done this number with a certain school, so I'm going to ask them to send you a photo and then they can do what? You can see through the working in case you can check. But the first thing you do, you have to remember. Okay, I don't remember. I don't remember. I'm going
Yeah. So they will send it. They will send in the group, right?
Yeah, they are going to send in the group.
All right. All right. Thank you, sir.
Okay. Yeah. So I think Olive.
Yes, sir. Teacher,
Yeah.
I'm requesting to know if the lessons are going to continue or they are going to stop today.
Okay. Okay, that one, I am still thinking about it. I'm still thinking. I'll give you feedback on that class group.
Okay, sir. Thank you.
But how many are still at home? In case you are still at home, kindly raise up your hand. I want to know how many people are still at home. Those who are not going to school tomorrow. Okay. Okay. So the people putting up are the people who are not going back tomorrow. Meaning you're going back next week, right? Let me allow you to unmute. Meaning you're going back the other week. Is that the meaning?
On 15th.
Yes,
15th.
Yes, teacher.
On 14th.
On 14th, eh? Okay.
Yes.
Okay. So I'm going to let me think about it. I'm going to think about it. Then I'll reply on WhatsApp group. But the lessons of 2, those ones ended. Those ones ended. Those ones for them, they ended. But this one of 5, I'm going to think about it. I'm going to think about it, then I will let you know through the WhatsApp group whether we shall continue having them. But if we are to just continue, just put for me in the chat which topics should we look at next.
Data collection.
You put in the chat such that I can choose.
Probability.
Okay, for probability, we have already looked at probability. So that one you are going to check on the YouTube channel. What about tomorrow morning? Okay, tomorrow morning we can meet. Tomorrow we can meet, and then we can look at when we meet tomorrow, we shall look at set theory. So tomorrow we shall look at set theory maybe, or I can first deal with let me first deal with number 1 first for those who are going, such that we look at number bases and other few basics for item 1. Yeah. So tomorrow that's what we are going to look at. Then the other time we shall look at then circle properties. Circle properties, I think we did it this year. Circle properties, Clara, we did it this year. I don't know whether maybe I can just share the videos on circle properties.
It's okay.
Yeah. Okay. Kale, let me wish you a good day. For the other numbers, I will do, and then I can share. When I get time, I will do, and then I will share with you. Yeah. Someone maybe can lead us in a word of prayer.
Chami.
Okay. You can
Yeah.
pray for us.
Yeah. Humble yourself for prayer. Father, King of Kings, thank you for this day. Thank you for this morning. Thank you for everyone who has attended. Thank you for our teacher. And thank you for our lives. Father, King, some people, this is their life lesson. Please enable them, please remember all that we've learned, because may have learned a lot from this. tough for me. So I thank the teacher and I thank you for the wisdom, knowledge. Everyone has their expectations. Some people want 9 A's. Some feel like 5 A's. And Father, please enable us to get at least an A in math, Father King of Glory, because we've struggled and practiced what we think is enough. Father King, give us the energy, give us the wisdom, knowledge, understanding, remembering to read until the last day, and we remember everything. Father, bless us, keep us safe, as it says in Numbers 6:22. Bless us and keep us safe. GIO people, teacher, give him blessings like never before. Help us alone without payment or something. So we thank you for our lives, for our parents. And thank you for the data we are using. Thank you for understanding and lead us throughout. Let us stay humble and kind. In Jesus' name I prayed. Amen.
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 Amen. Bye. Let's meet tomorrow. Yeah.
Thank you.